What is alternating current? Most students of electricity begin their study with what is known as direct, which is electricity flowing in a constant direction and possessing a voltage with constant polarity. This is kind of electricity made by battery with definitely positive and negative terminals are the kind of charge generated by rubbing certain types of material against each other. Alternating current was a direct current as useful as easy to understand as DC. It is not the only kind of electricity in use. Certain sources of electricity, most notably rotary electromechanical generators, naturally produce voltage alternating in polarity, reversing positive and negative over time, either as a voltage switching polarity or as a current switching direct back and forth. This kind of electricity is known as an alternating current. Whereas a familiar battery symbol is used as generating symbol for any DC voltage source. The circle with wavy line inside in the generic symbol of any AC voltage source. One might wonder why anyone would bother with such a thing as AC. It is the true that in some cases AC holds no practicable advantage over DC. In application where electricity is used to dissipate energy in the form of heat, the polarity or direction of the current is irrelevant. As long as there is enough voltage and current to the load to produce a desired heat power dissipation. However, with AC, it is possible to build electric generator motors, power distribution systems that are far from efficient than DC, and so we find AC being used predominantly across the world in high power applications. To explain the details of why this is so, a bit of background knowledge about AC necessary. If a machine is constructed to rotate magnetic field around a set of stationary wire coils with the turning of shaft, AC voltage will be produced across the wire coils as that shaft is rotated in accordance with the Faraday's law of electromagnetic induction. This is the basic operating principle of an AC generator, also known as alternator. Notice how the polarity of voltage across to the wire coil reverses as the opposite poles of rotating magnet pass by. Connected to a load, this reversing voltage polarity will creating reverse current direction in the circle. Faster the alternate shaft is turned, the faster the magnet will spin, resulting in an alternating voltage current that switches direction more often in given amount of time. While DC generators work on same general principle of electromagnetic induction, their construction is not as simple as their AC counterparts. With DC generator, the coil of wire is mounted in the shaft where the magnet is on the AC alternator and electrical connection are made on the spinning coil while the stationary carbon brushes contacting copper strips on the rotating shaft. All this is necessary to switch the coils, changing output polarity to the external circuit so the external circuit sees a constant polarity. Generator shown above will produce two pulses of voltage per revolution of the shaft, both pulses in the same direction in order for DC generator to produce constant voltage rather than brief pulses of voltage once every half revolution. There are multiple sets of coil making intermittent contact with the brushes. The diagram shown above is a bit more simplified than what you used to see in real life. The problem involved with making and breaking electrical contact with the moving coil should be obvious sparking and heating, especially if the shaft of generator is revolving at high speed. If the atmosphere surrounding the machine contains flammable explosive vapors, the practical problem of spark producing brush contacts is even greater. An AC generator landing does not require brushes and commutator to work and so immune so these problems experienced by DC generator. AC motor, the benefits of AC over DC with regard to generator design are also reflected in electric motors. While DC motor require the use of brushes to make electrical contact with the moving coils of wire, AC motors do not. In fact, AC and DC motor design are very similar to their generator counterparts, identical for the sake of tutorial. And the AC motor being dependent upon the reversing magnet field producing alternating current through its stationary coils of wire to rotate the rotating magnet around its shaft, and the DC motor being dependent on the brush making and breaking connection to reverse current through the rotating coil 1 over 2 rotation 180 degrees.